Hello and welcome to my video on the pendulum's period. So we have a formula for the period of a pendulum. Before we get into that, it only applies for small angles. This is an approximation, and it's a good approximation. It has less than 1% error up until the angles that are greater than 22 degrees. So that doesn't really matter. All you have to know is only works for small angles. Okay, the rest of it don't need to know, but you have to know it's small angles. And you also don't need to know this, but it's very interesting for our course. But sine theta equals theta for small angles, and that's the assumption that's being made here, and that's why they're doing this. So basically, it's this whole thing, and then it's times sine theta is actually what's happening, and so it approximates this to be equal to theta for small angles, because when theta is 0, then sine theta is also 0. Okay, and so that's kind of the big idea here. That's not quite right, but it's kind of the big idea. So let's continue on and try some questions with this beautiful approximation that is pretty darn close. It's not quite right, but it's pretty darn close. I guess it's sine 0 equals, sine 0. Anyways, so assume you could take a 26.4 centimeter long pendulum clock to the moon, where the acceleration due to gravity is 1/6 of what it is on Earth. Determine the period of your clock on the moon. So let's solve for the period. Period is just t. We've got 2 pi, and then we've got the square root of length, which I use this little cursive when I'm writing it, and then over g, which is gravity. Okay, so what does it say? Well, it says that it's the length is 26.4. Now you have to be careful because we need to measure this in meters. So 0.264 meters over, well, 9.81? Nope, not quite. It's 1/6 of what it is on Earth. So we're going to multiply that by 1/6 or divide by 1/6, however you want to look at that. So this would be the equation. So let's go ahead and plug that in our calculator and see what we get. Whoops, actually I need to go 2 times pi times square root of 0.264 over 9.81, and I'm going to just divide by 6. I think that's probably easier just in terms of typing it in. So 2.52, and we've got 3 sig digs, so yeah, 2.52 seconds. All right, and that would be our final answer. It's actually that simple. So the question here is for part B: does the clock appear to run faster or slower than when compared to on Earth? Well, we just have to do the same thing, but for on Earth. So on Earth would mean that we're using the regular 9.81. There's no divide by 6. So let's try that again, but get rid of the divide by 6. So then it says 1.03. So the period is a smaller period on Earth. So what does that actually mean? Well, it means that on the moon, every cycle takes more time. And that is actually something we don't need to calculate both sides of. All we can do is look at g and notice that it's dividing by the square root of g. So it's dividing by square root of g, and so therefore if g is a larger number, then it makes the whole thing the period smaller. If g is a smaller number, it makes the whole thing bigger. So don't have to go through the process of calculating both, but I think it might make it clear when we do. Okay, let's try another question here where we're solving for a different part. So this time we're solving for the length of a symbol pendulum. Okay, the length of it when it is adjusted to swing with a period of 2 seconds. Okay, and I assume this is on Earth. It should say that, but I mean, yes, it is on Earth. So let's just go through. This is opposite operators, opposite bed mass. The key here is to follow that. And if you follow that, it will make things wonderfully work. The only thing you have to keep in mind is that a square root is an exponent, and that the thing inside of the square root is automatically inside of brackets. Okay, so you just have to think about those two things, but if you keep those in mind, it's actually pretty straightforward. So what's our first thing? Well, we don't have adding or subtraction, so the first thing is to divide by 2 pi on both sides of our equal sign. So divide by 2 pi, and we get t over 2 pi equals the square root of L over G. All right, so what we want to do still, we're not done yet, we want to solve for L. So what's the next step we do? The next step is to square both sides, because we want to get rid of the square root, so we need to square both sides. So that will get rid of the square root, so we're going to be left with t squared over 4 pi squared equals L over G. Now we want to solve for the L, sorry. So what do we have to do? One last thing, multiply by G on both sides. Cancel, cancel. We're left with t squared G over 4 pi squared. Okay, so let's go ahead and plug in those values for ourselves here. Period is 2.0. So 2 squared times 9.81 over 4 times pi squared equals 0.99396. And this is meters. Okay, so considering we have 3 sig digs here, we should have 3 sig digs here as well. So our final answer is 0.994 meters. All right, this is going to be very similar. It's going to be like half a step more, so keep in mind what we just did. I recommend you pause the video, try it yourself, and see what you get. All right, so we are going to try to solve this one for what? Well, we're trying to find the acceleration due to gravity, and we're given the length of the pendulum, and we are also given the time it takes. Just notice one thing about this. It's a little bit counterintuitive, but in this formula we have t, which is period, and we have length of the string, and we have gravity. Nothing else affects the period, only these things. So keep that in mind. Nothing else affects the period, only these things. And surprisingly and counterintuitively, mass does not affect the period. So I would keep that in mind just for those word problems when it's not a calculation. But anyways, here you go. Let's take a look. So we've got we've got this. We're trying to solve for G, trying to solve for the acceleration due to gravity. So first thing we have to do, just like before, divide by 2 pi on both sides. Okay, so we're left with t over 2 pi. And on this side, we've got the square root of L over G. Again, it's very similar to the last question. Not a lot has changed. Okay, and then what we need to do is square both sides. Again, same as last question. Nothing has changed. There will be a difference at the very end here, but not yet. And then we have L over G. Well, the difference here is that we want to get G by itself. There are two different ways to do this. I'm going to show you the way that I think makes most sense for most people, which is to keep sticking with opposite operators. We want to get our G, our unknown, on top and by itself. So let's get it on top first. So then we have T squared times G over 4 pi squared equals L. Okay, and then what we can do is times by 4 pi squared on both sides and T squared on both sides, so 4 squared over T squared. This cancels with this cancels with this, so we're left with G equals 4 pi squared L over T squared. Okay, I will say that from the red step, we could instead do reciprocals on both sides, and that is fine as well, as long as you understand reciprocals. Okay, so we could do this, and that would work just fine. You just have to be careful to make sure that you understand what you're doing. But if you do, then you can flip both sides, and as long as you're doing it to both sides, it's okay. And then you solve for G by multiplying by L on both sides, and this cancels, and so we're left with G. And then on this side we have 4 pi squared L and then T squared. So most people find the reciprocal faster and easier, but I just don't want you to make a mistake, so I want to show both methods. So let's go ahead and actually try this out this time. Oh, that's annoying. There you go. So let's try this out this time with 4 pi squared times 1, which is the length of the string, over 2 squared, which is the period, and we get 9.8696. I think that's right. Okay, and that again, that comes from either one of these. These are the same as each other, they're equal, and that's meters per second squared. But we want to simplify to 2 sig digs, so 9.9 meters per second squared. And that would be our final answer. Alright, I hope that this video helps you better understand pendulums and their period, and especially rearranging an algebra in these sorts of examples. I hope this video helped, and good luck!